How's it going?
Good, how are you?
I'm good. We'll give each other, or give the other guys a couple minutes to filter in if anybody shows. You guys have a good weekend?
Yeah, it was pretty good. Sorry, it wouldn't play any audio for a second there. I don't know. Did you say something before that? Yeah, no, I had a good weekend though. Nothing too crazy. You know, being quarantined.
Yeah. Yeah. Same plans every night, right?
Come home and do homework if I feel like it.
Yeah. How are your other classes going?
This is my class, so I got
okay.
lucky. I went to Merrimack for like 3 different majors before this. So.
Oh, okay.
Same here.
Yeah. Yeah, that's how I was too. I had probably 30 credit hours rolling in the ranking, so I only needed to take a couple classes to get the associates.
Right. Yeah, it was like I had to take like business.
Dow.
Yeah.
And that's it.
Business communications.
Yep.
Yeah.
Today.
Computer was fighting me a minute ago, so we'll see. Hopefully it's calmed down. Still depends on how long SolidWorks takes to start up.
Yeah, it's been giving me some trouble.
Well, I'm used to like the computer they got me at work has a solid state disk in it, and my laptop, my like personal laptop, has a solid state disk in it, and this does not, and so it's just the load times are
a little slower.
Yeah.
I've got a split. My solid state, which is goofy. My solid state is my storage partition, and then my my actual hard drive is what it runs everything off of. I'm not sure why they set it up that way, but
that is
like the
that's really weird. Yeah. Exact opposite of how you would normally do it.
Yeah.
Oh,
Mr. Durkee.
Yeah.
Do you know anything about the plans for graduation yet?
I have no idea, Jacob. I am in the same, like I get the same emails that you did. Actually, they sent that email that they sent out. They just sent the exact same version to the staff. There weren't even any changes or any privy information or anything.
Any updates on whether or not we might have an extended semester at all?
That would be, my guess is either we would have an extended semester or you guys, or there's going to have to be an exception made by the Higher Learning Commission, or they'll have you guys finish this part of the semester and then have you guys come in at a later date and do like, basically what I've been told is try to think of a project that they could get done in a week, or a series of projects that they get done in a week's worth of class time, which is basically what we're doing anyway.
Right.
That's kind of how I look at it, is you guys are making your parts and programming them, and then
we get come in and run them.
Exactly. So that was kind of my thought, was not really doing anything a whole lot different.
Yeah, I'm not gonna lie, I kind of miss the actual in-shop time. It gives you a little less pressure than being at my actual job, to perform. I get to screw up a little bit if I need to, or.
Yeah. Yeah, that's when you talk to kids that are coming in, they're trying to figure out, should I try to go find a job, or should I go to school? That's one of the things I always tell them is, I'm not going to yell at you if you break something. Yeah, unless it's something huge,
right?
Or it's you.
Right.
But yeah, I mean, if you're just breaking an end mill or something like that, mistakes happen. That's kind of what you're here for.
Well, you can almost have to break some stuff just to learn.
Oh yeah. Oh, absolutely. I always say that I feel like I made almost every mistake I could think of at least once.
Right.
And that's just kind of how you learn. And yeah, it's a little bit nicer doing that in a shop environment than work. Or I mean,
Actually get in trouble.
yeah, or worry about getting fired or stuff like that. Yeah, like the very first time we had this old, I don't know if I've told you guys this before, but we had this old say Giddings and Lewis, I think it was, horizontal boring mill, and it was a really nice machine. It was probably like 50 years old, 60 years old, like made in the 60s, 50s, 60s. It was just a beast. It was really set up really nice, ran really nice, all that stuff. And so the head moves up on ways just like any other mill, and but it has a head. Just like any other mill, you have your weigh clamps that you turn on. The difference with this guy is the head is probably it was like a cube of steel, and cast iron is probably 4 feet by 4 feet by 6 feet. So it weighed thousands of pounds, right? So this head moves up on these gibs and these ways, and so they set me up on it, and they're like, all right, Paul, you're just doing this one thing, not really a whole lot to it. You'll be able to do it. So they spent like 5 minutes setting me up, and I ran it, and ran it for about half of a day, and didn't understand that you really had to make sure you turned off the weigh clamps for that head when you move it up and down, or else you'll gall up the clamps and freeze the head halfway up on the travel. And so that's what I did.
Oh, no.
And yeah, I that's really the closest or the most I ever thought that I was going to get fired in a machine shop. It ended up being about $5,000 worth of damage to it.
That's actually not.
No.
That is.
And that's actually having somebody come fly somebody in to come fix it too. Yeah, originally we were thinking it'd be like 20 or 30 to fix it, because they thought they were gonna have to disassemble the whole thing and bring in a crane, and because they couldn't, I'm not even sure they would be able to disassemble it fully without removing part of the roof. It was just I took a walk for lunch that day instead of eating. It was good times.
I had to hand me once.
Yeah.
So part in a CNC,
Mm-hmm.
tip it down, hit it, instead of flying, knock the CNC off.
Oh wow. Yeah. Those are the ones those are the kinds of mistakes. I can tell you for one thing, for sure, if I ever run that mill again, I sure am not going to leave the head clamps on. I know that. But also, I felt bad too, because it's like you run these old machines, and you almost feel like you're, like you're kind of taking care of this machine for history.
Right.
And so it's like, part of me felt bad just because it was like, this is like a 60-year-old machine, and my dumbass is the one that like messed up the gibs. And it actually wasn't that bad, but
Right.
it was, felt bad about that too. All right, so let's get started. Today we're gonna talk about we are going to do some Solidworks. There we go. All right, so we've talked about drawing, and basically what I wanted to go through is just maybe we'll draw a part or draw a couple parts, and then we're going to actually start getting into drawings and how to convert these parts into an actual schematic that's usable for other people, right? So we're gonna go how to convert or how to transfer it over, then how to import our dimensions, and then we'll also talk about how to format our dimensions a little bit more. Oops, wrong way, there we are. All right, so what we're gonna do is just kind of keep things moving along. We'll do parts number 5 and 6. I'll just draw those out. Already kind of started on part 5 the other day, but I'll just draw the whole thing out today.
Part 5 is the one with those two little side dimple things on it.
Yeah. Part 5 is going to be, well, I guess I'm just sharing this screen so I can, so part 5 is going to be that guy.
Yeah, it took me a while to figure that one out for sure.
Yeah. yeah, the revolve's a little tricky, but also the geometry on there is a little tricky as well. So one of the things we can do is if we just kind of look at it. All right, so we have, I'm going to zoom in here. So if we look at that guy, basically what we have is a square with a radius on the ends. All right, so this radius is half of an inch and a quarter, so it'd be what, 5/8. So we have this radius that's 5/8 on each side, and then we can also kind of infer that the width of this flat is the same as the center spacing on these holes. Just from looking at that, we see our extension line basically goes up through there. It's not called out anywhere else, so that's we'll just kind of assume there. So because of that, because that's our kind of our geometry, we can kind of use that to our advantage. Let's see, I'm just going to do top plane. And so I'm just going to do a center rectangle here. All right, so our center rectangle is going to anchor this to the center point is what we're clicking on, and then we can come out here. So before you even ever do any of my other geometry, I'm just going to go ahead and start dimensioning this section of it, which will make my life a little bit easier here in a minute. All right, so that's all we really need to do, just give it our top dimension. There is one thing there, since that is a since that's a two-dimensional tolerance, I'm going to change that to 3 because that's how it's called out on our print. Same thing there.
That was something you I think you had mentioned a couple weeks back, something about how we can set it up to automatically dimension things to 3 decimal places. How do we go about doing that?
Okay, cool. Yeah, so basically in order to do that, we need to change the settings for this document. So if we go up here to our very top and in the options drop down, when we go into options, we have 2 different choices on options. We have our document properties and our system options. So system options are going to be system-wide changes, right? So if we make a change to here, it's going to be a change every single time we ever open up SolidWorks on this computer. That change will be enabled. So the really common ones that we change, or that I like to change, is like dangling dimensions, or sorry, non-imported dimensions. So, and I'll actually get back into this later because we'll see the difference more when we get into drawings. But like this non-imported, I usually change that to black. So these are system-wide settings, right? So it's not specific to our document. So we can change all those. But what we're talking about here is we're talking about changing our unit precision, right, or our units. So we actually want to get into document properties to change units. So if you go to units, we have our unit systems that we can select from. Most of them are going to be in metric. We want inches, pounds, seconds. And then down here, we have basic units, mass section, motion units. It's basically all of our different units that we're going to be getting information in, right? So for length, all you need to do is just go down here and change this to 3. And now my drafting standard has been changed. Since we're in here, I like to just change my angles to 0. Or to none, because most of the time you're going to see an angle, it's going to be dimensioned to a full degree. And then we have dual dimension length. So usually it's 2 decimal places. Then we click OK. So this has saved that for this one document. But typically when we're doing this, if we change this is kind of a change we want to make all the time. So we can save this as a template right now. So if you save it as a template, a part template, I can say that this is going to be, it's a part file, and it's going to be x.xxx. So that's just saying, I just use the x as a placeholder for numbers. So that's just telling me that this is going to be a 3 decimal place template. And so now I click save. And so right now, if I continue to change this, it's going to still be my my template, right? And so any changes I make to this are not actually changing to my document, it's changing it to my template. So because of that, I'm going to say actually go back and save this as a part file again. All right, so if I go back, save it as a part, I'm going to find my boring head. There we go. I'm just going to call that set boring head part 5.
So at that point, you just open up the template anytime you want to start up a new drawing with those properties?
Exactly, yeah. So if I wanted to create a new document with those exact same settings, when I go to create a new document, instead of being in here, right, this is like our kind of basic format. So all of these are just my basic templates. If I have more templates that I know, I can use this advanced tab down here. Right, so at that point, now I see my part x.xxx. The problem with this is when I create a new file, it's going to save this block in there.
So you want to kind of change those properties before you start drawing, save it as a template, and then reopen it whenever you.
Yeah, yeah. Ideally, if you know you're gonna be making a template, you would start it before you start drawing anything in there. Or you can you can do your template and then just delete. Like if I was going to open up that, if I wanted to change the template, I could open up the template, delete the sketch, and then resave that template. I'm not going to for that purpose. But yeah, basically, we'd want to have a blank file whenever we create a template. Unless you know exactly what you're looking for. Because you can, in certain circumstances, you could, like say you had a part size that, wherever you work, that part, you have a lot of different variations on that part. You could set up a template for that part, and then you'd basically just be adjusting that one part to create a new file. So you could do something like that. But yeah, most of the time you're going to have a blank file for your templates.
Good to know.
All right. So right now I'm still in my part, but I'm out of my sketch. So I'm going to go back and edit sketch. And from here, I'm going to do 3-point arcs. So a 3-point arc is basically you're selecting the endpoints of the arc first. So all I'm going to do is just click like so. I want to try to have this where it's not clicking, like it's not snapping to anything. Right, so like if I come here and it snaps to this, what it's snapping to is this is a 90-degree arc. Right, so if I look at that, my radius is kind of goofy. It's 566. My arc, or my A, is 90 degrees. So it's going to want to snap to certain spots. But if you can kind of avoid it to where it doesn't snap, that's going to, sometimes it will actually create relations or kind of create something when you let it snap to something.
Yeah, I was dealing with that all day yesterday.
Yeah. Yeah, sometimes it'll snap to a different piece of geometry, and you're like, it's almost like it locks it in, but it won't actually have a displayed relation there. It's kind of a weird gray area in SolidWorks. Yeah, I've had that happen a lot of times.
I just did a circle for mine.
But you can do that too. All right, so from here, we want to make both these arcs equal. Right, so it's going to have the same radius. That way I only have to dimension in one side. And I'm just going to dimension that. So that's going to be 625, which is also pretty funny. Yeah, well, I guess that does make sense. And then from here, we can delete the top, or delete the side, delete that side. All right, and so now all I'm going to do is I'm just going to create 2 circles out here. I'm going to put in a center line here. Right, so I could leave I could just kind of dimension both these, or do a mirror. Either one would work, but we'll just kind of do this a little differently. All right, so that's our center line. It's coincident there, and I'm just going to fix it. So fixing it's going to freeze this in position. So when I make a relation between any geometry and the center line, instead of possibly moving my center line and leaving my geometry where it is, or moving both of them, that happens too. Now, because this is fixed, nothing will move my center line. Nothing can move it. So with this, I'm just going to select my center line. I'm going to select both of these circles. I'm going to do a symmetric relationship. So I click symmetric, and that's it. So now when I dimension this guy, so this is going to be 660 from the center. It's going to move both of my circles, and then that's going to be 200 from the top. And then I need to dimension this guy. All right, so I'm going to dimension that, and that is going to be a 1/4 inch diameter. But if you noticed, it mirrored these geometry-wise, but it did not mirror the size of this, right? So on one side we're 250, on the other side is 247. So in order to make those the same, I'm just going to control. So I'm holding down the control button and click on my second part. I'm just going to create or make these equal. All right, so I have one dimensioned, so that means that this is fully defined as well. So that's really all we need there. All right, so from here, now we can go through and we can trim. So I'm just going to trim that, and I'm going to do the same thing over there. Love that power trim tool. All right. So we're still good there. So now I'm just going to go ahead and put my center hole in. And oh, I always forget to tell you guys this at the beginning. I usually kind of wait. One of my favorite shortcuts in Solidworks is the S key. Wherever your pointer is, if you hit the S key, and it's easy to remember, Solidworks starts with an S. It brings up the same menu as when you right click, or not right click, but basically what pops up is the draw or sketch menu. So in this little menu, I have my smart dimensions, I have my line tools, I have my polygon tools, my chamfer, trim entities, offset. I basically have almost all of these, all the same tools that I have up here. So this can really save you some time, because instead of having to go up here every time and then back down, you can just hit your S key and it works pretty well. So I'm just going to dimension that guy. It's going to be 450 all the way through. And then I'm going to extrude. So it's going to be 440. Just hit enter a couple times, and now we got it. All right, and so my sketch lines are still showing because I basically have my boss selected. Once I click on that, it'll disappear. Okay. So from here, we are going to create a counter bore on our for our through hole. All right, so I'm just going to create a sketch on that surface. I'm going to create my counter bore. I'm going to I'm going to create my circle. Dimension said circle to 685. And I'm going to do an extruded cut with that guy down 150 thou. Hit enter, and now I got my counter bore. And so since I'm here, I'm already have it set up. I'm just going to go ahead and put my those 3/16 holes through. So I'll just select that surface because I know that's where the holes are going to go. I'm going to select my hole wizard. And I'm just going to do a standard through hole. So I did some custom sizing with this guy, so I'm just going to say reset to your standard hole sizes. And then from here, I'm just going to go fractional drill sizes and 3/16. And this is going through all, don't need custom sizing or anything like that. And then, I guess that is there. All right. So same thing, I'm just going to create a center point. And I'm going to select this guy. I'm going to select my origin, and I'm going to select this left hole. And I'm going to create these to make them, I'm going to make them all horizontal. So the center point or the origin of this is never going to move, right? If I move my part, my origin is still going to stay in the same spot. But I have all of this centered around my origin. So when I put this horizontal with my origin, I know that this is going to be in the center of my part. And then I'm just going to make these symmetrical. So control click, select all three. And then I'm just clicking symmetric and clicking OK. And so now I can dimension these. So they're 0.965, and that's going to put them almost exactly where they were. Click OK, and now they're all the way through. And just to make it pretty, I'll change the material to brass too. Ain't that shiny. All right, now before I get too far, my favorite mistake to make is to not save my parts. So just rename that part number 5. And now we can do our, marks. Don't know why. You really want to be upside down, don't you? There we go. Okay. So I kind of talked about this the other day. These are not really, well, I guess we could just say they are going out to the diameter. So, excuse me. So what we're going to do is we're just going to create a sketch on that surface, and we'll create a line that's going to go up like so. All right, and then we are going to, that's all we need for that sketch. And so now we'll create a plane for the end of this guy. So we want to create a plane so we can draw a geometry that's right on the end of this line. And an easy way to do that is figure out what plane is going to be parallel with that. So if that's our front plane, if I shifted my front plane up so it was coincident with that part, that would be exactly where I need it. So I can do that pretty easily since I already have my front plane selected. When I go and create a new reference plane, it's going to automatically create it in relation to that. So by default, what it's going to do is it's going to do an offset. It's going to keep it parallel with my original plane, my front plane, but it's just going to offset it in whatever direction I want. I could offset this and figure out exactly where that is or whatever, or I can just select a second reference. So if I select a second reference, it's not going to do this offset distance. What it'll do is it'll default to a parallel. Right, so if I select that, well, maybe it won't default. I may have to select it in a parallel. Since I messed around with the distance, I think that's what goofed it up. But usually, all right, so now I have a plane that's parallel with my front plane, but coincident with this point. And so now I will create a drawing on that plane. Or create a sketch on that plane. And so all I'm going to do is I'm going to create a triangle. I'm going to use my polygon tool and just set it to 3 sides. And I'm just going to go up like that. And I can set how deep this is engraved. Let's say 15 thou. Oops, not like that. So you notice that when I change that, maybe you notice I changed that it turned my triangle for some reason. Don't know why it's doing that. So what I can do to force this into keeping the same position is, let's think about, I want this to be perfectly over this point here, right? Well, I can create that relation, which is going to force that geometry to stay in the position that I want it. So if I click make vertical, right, it's going to satisfy this dimension, 17th thou, but it's also has to satisfy that relationship. So if I put in 15th thou now, instead of turning my triangle around, it's going to shift it down to the position that I want it at. Okay, so we can click close. And now we can do a swept cut. So sometimes, we'll see what happens. Sometimes with these, you can select both of your sketches that you want to use for your swept cut, or you can start off with one. We'll start off with 0, how about that? So I click swept cut, and the first thing it's going to ask me for is the profile. So the profile is the shape that we're cutting. So I'll just select anywhere in that, on that sketch, because it's going to use the entire sketch for that geometry, and then it's going to say what path do you want to take for that cut. So I'm just going to select that, and we will click OK, and that creates our little line like so. All right, so now we have that. Oops, I'm also going to hide our plane that we created. All right, so our cut sweep, this is where we can take this guy and revolve it around. Really wants to put my part upside down for some reason. All right, so from here, all we're going to do is we're going to do a circular sketch pattern. So we talked about this last week. There are really two ways we can do a sketch pattern. We can do a pattern. We can do a pattern inside a sketch, or we can do a feature pattern. So we want to do a feature pattern because this is already an extrusion. We could have done this where we set this up and sweep just the lines around, but then we're gonna have to go back in and make these extrusions, and so that's a little more work. So the easier way of doing this is I'm gonna select that cut, and then I'm gonna go into circular pattern. So these long lines, there's gonna be 5 of these. 1, 2, 3, 4, 5. So 360 divided by 5 is going to be our spacing on here. And then we need to select where we're rotating around. So we can just select that circle. And now, all right, we see our first feature up here. So we're going to select 5. We're going to have 5 in total. And we'll click OK. All right, so now we have our big lines. Well, I'm going to go back. Well, you'd think I'd learn. I'd learn not to do that. But keep doing it every time. All right, so we're going to. So next, we're going to do is we're just going to create our other geometry. All right. So in this case, we have one line that's going to be what? I can't remember exactly. So it will take 360 divided by 25. I can't remember what the number was. But before we do that, we're going to create a sketch, and we're just going to draw a line. So we're going to draw it a little bit longer on this end, but it's going to be shorter on that end. And so we could do this a couple different ways. So another way we could do this is if we created a center line and then just have a regular line coming up. That's another way we could do it. And we could make these collinear, force those into a relationship. And now we can, oops, now we should be able to rotate this around. All right, so well, we want this guy to be, 360 divided by 25 is going to be 14.4 degrees. 14.38 probably. No, 14.4. That's right. All right, so from here, what we're going to do is we're going to create another plane. So what I can't do is I can't select my front plane and say, all right, I'm going to create my front plane, or I'm going to create a front plane that is parallel with this and then coincident with that, because that's going to create a plane, those things, which is not going to be perpendicular to this, which is really what I want. So what I'm going to have to do is probably get a little, I'm going to have to think about this a little bit. So if I look at my top plane, if I create a top plane that is perpendicular to a plane that is perpendicular to my top plane, that would start to put it in the right direction. So that's where I'm going to start. So oops, I need to close that sketch out. So I'll create a reference plane. So it's going to be perpendicular to my top plane. And then I'm going to have it coincident with that, and then perpendicular to that line. Well, how is that not enough information? Okay. Let's see. Nope, don't want an axis. There we go. All right. So what we can do instead, I guess I was just trying to do too much with it. If we create a plane, perpendicular to that line and then coincident with that point, that's going to give it enough information on where to figure it out. All right, so we'll click OK there. And so now we have this plane here, right? So plane 2. So from here, I'm just going to again create a sketch. And again, I will create a triangle. And I'm just going to put it on that. I'm going to create a relation between my endpoint and my center point to be vertical. And then I'm going to dimension that point to that point. All right, I'm going to have it 15 thou. And I can close that, hide my plane. All right, so now I can do another swept cut. And then like so. And then I think about that, I'm going to actually delete this pattern. So we could do this how it is right now, but it's actually going to kind of make it a little bit more difficult. So if I try to pattern these how they are right now, I'm going to have to pattern 4 of these, then skip 1, then 4, skip 1, then 4, skip 1, 4, and so on. If I, instead of doing it that way, if I delete this pattern here, now I can make a pattern of just this one. So I'm going to create a circular pattern for that guy. And again, select a circle. Oops, wrong circle. There we go. So I want 4 of these, and this is going to be 360 divided by 25 again. And we'll click OK. All right, so now I have a full set of these. I have 1 long one, 4 short ones, right? Because every 5th line is going to be a long one. So now with this, I can highlight these 5, these 3 features, which circular pattern is going to be 3 of these lines. This cut sweep is going to be that line. And this cut sweep is going to be that line. And so now I can take these guys and do a circular pattern. And then that is going to be 360 divided by 5, which is going to be 72 degrees. We'll say there's going to be 5 of these. I can click OK. And so now we have our dividers on our part. Now, like I said last week, this is not super duper useful for you. I mean, it makes your part look more or less like what it's going to look like.
Yeah, I went ahead and I just skipped it in SolidWorks and just toolpathed it in Mastercam because it seemed like it was a little quicker anyway.
Yeah, I mean, doing it this way is really just kind of more extra work. You can do it if you like really had some reason to make a more accurate model. Like if you're drawing something up for a customer and you wanted it to look exactly like it's going to look like, then I would do this. But that's probably about the only reason I would do this. Yeah, every other time I would do exactly what you said. I'd take it in the Mastercam and just draw some lines, because that's really all you need. All right, so we got that as a part, right? We have our completed part file. So this isn't super useful for us all on its own. I mean, we can obviously import this into Mastercam, or I guess export it since we're in SolidWorks into Mastercam. But that's probably not something we're gonna be dying to do. Well, I mean, obviously that's something we're gonna do, but even when we do that, we're probably still gonna want a piece of paper or a drawing so we can figure out these dimensions. I mean, obviously, if we go into evaluate, or missed it. If we go into our evaluate tab up here, we can use our measure function. We can measure like the diameter of these holes, the size of these radii. We can figure out where, what our center distance is in X and Y, and our normal distance. We can figure all that stuff out. But as you can imagine, this is kind of a not a great way to get our dimensions, right? It's another thing we can do, like mass properties. You can use your mass properties tool and say, all right, well, this is going to be 0.31 pounds if I make this out of brass, right? So a little bit more than a quarter of a pound. Right, gives us lots of information. But we probably want a print, right? We're probably going to want to print. So before you start your print, best piece of advice I can give you is to save your file. And then from here, when we go up here at our top, for the new button, instead of hitting the new, if we hit that arrow right next to it, it gives us 2 additional options here. We can make a drawing from a part assembly, or we can make an assembly from part assembly. And you can make assembly from part assembly. It kind of sounds weird, but one of the things that really makes SolidWorks powerful is you can make assemblies inside of assemblies, inside of assemblies, inside of assemblies. So, if you have a component that's made of parts that's going to go in a lot of different places, we can save that assembly and actually insert that into other assemblies. If you think about if you're going to be making a house, right? Those 2x4 studs in the walls are always the same. They're always the same size. They're usually in the same kind of formation. So if we wanted to make 4 walls, we don't necessarily have to draw all 4 of those walls. We could create a standard wall and then use that 4 times, or use it 4 times and then adapt it. But we'll get in that later. So what we're going to do here is we're actually going to create a drawing. So make drawing from assembly, and it puts us back into our little file selector thing here, right? So we're just going to create a regular drawing, and it's going to ask us what format we want. There's a little bug in SolidWorks that I always think is interesting, because it'll always default to millimeters when you open up a drawing, when you go to create a drawing. So like this landscape, this A landscape this is an 8.5 by 11 sheet of paper. So it's going to scale things based on an 8.5 by 11. B is going to be a tabloid size. Or I'm sorry, that's not tabloid. Anyway, basically we just have different paper sizes that we can use. But if you click on here and you go to A and it's in millimeters, it's just, if you click on anything else and back to A, it'll be back in inches. All right, so let's do a porch. No, let's do landscape. So we click on landscape and it's going to open up a completely blank, well, not completely blank, almost completely blank part or drawing file. So at this point, we don't have anything right now. But what it also defaults to is on the right here is your view palette. So basically what we have here are all the different views of our part: top, front, right, left, back, bottom. You know, we have a few ISOs. This is actually our current view. So if I was in here and, you know, for some reason, this is the perfect view to see this part from, right? It's not, but let's say it was. Well, when I come over here to my view palette, click refresh, well, you can see my current view is exactly what my part is, exactly how my part is currently orientated in that part file. So that can be helpful as well if you have kind of a weird shaped part. So how we use this is really we just figure out which one we really want to use first. So that bottom part kind of looks the most like our part file. So I'm just going to drag that out. And so once I have an initial view, what's going to do is going to do a parallel projection, or a projection of that view when I drag my mouse around. All right, so if this is my top view, that's going to be my front, back, right, left. And then I can also, if I go up in an angle, I can do an isometric view as well. So whichever one I want to keep, like say I want that guy, I'll just pull that out and I'll click, and that will automatically put it out there. And then it's also kind of nice to have an ISO view, so I like to put my ISO view in the corner. And then once we're done with those ISO, you know, picking out our views, we can hit escape and it'll close our view palette. But if you ever need another one of those views, you can always come back up and drag these views out, which is handy. The other thing we can do is if I have a view in here and I'm like, all right, well, I have my front and my right view. I really want a top view here also. I can left click on this and my little dialog box pops open. All right, so my first option is open part position, or projected view, or hide show edges. So if I do projected view, basically it's just going to reopen that selection I started out with. So if I wanted to add that front view, I still can. Right. I do not want my front view, so I'm going to go there. All right, so that's pretty self-explanatory. I mean, that's pretty straightforward. So once we have these views designated, this left column kind of changes meanings. So when I click on this, this is going to be all my information specific to this view, right? So if I'm on my front view, I'm going to have more information here, and that's because this is the view I started off with, right? I made projections based off of this view, so there's going to be a little more information here. So I can change all sorts of stuff here, like if I wanted to change how this is viewed, right? So if I look on my blueprint, this has hidden lines visible. Well, right now, no hidden lines are visible. Well, if I go to display style, I can basically select different styles based on what I want here. So I'm just going to select, well, first I'm going to just select regular. And before I change that, what I'm going to do is I'm going to go around and change my settings on these parts. I have seen a few prints here and there that have, like on the ISO view, have hidden lines visible. I've never really understood why people do that, but but when I click on this ISO view on my display style, there's this little checkbox that says use parent style. So the parent for this is my first view, right? So if you think back, this is my first view I pulled on, and I pulled projections of this view out of this. So this is the base view. This is what everything is based off of. So if I want to change this into any, if I want to change this at all, it's going to, or if I change this view, it's going to change everything in this ISO. Well, I don't want that. I want it to stay in a solid view. But also, I like to make this smaller than my other parts. So that's what this scale does, right? So if I use parent scale, it's just going to fix it to whatever scale I make this. If I use sheet scale, well, it's just going to use this 2:1. All right, that's what, when we have scale on the sheet, that's what it's for. But I like to make it a little smaller just so it doesn't take up as much room. All right, so if I click that now, so now when I change this to hidden lines visible, I won't see them up here. If I change the size on this, it's not going to change this up here. So from here, we can go back and you can select hidden lines, right? Keeps that guy looking original, but also I'm going to increase my scale a little bit. Oh, maybe 2 to 3. No, wrong way. Wrong way, Paul. All right, so 2:1 is that. 4:1 is going to be a little big. Maybe 3:1 will be just right. So 3:1 is not my drop down. So what I can actually do is use a user defined. And at this point, I can say, I can put in whatever I want here. So 3:1 looks pretty good. You know, I could say 5:2. So, yeah, a little bit smaller. Actually, I think that might be in my list. Nope. So pretty good, right? So now we have our basic part. We want to save this. Nice thing is it will default to the original file name. So we'll just save that. And the reason I wanted to save that is because this is one of those things that I'm going to show you that will frequently crash your part or your file. So sometimes both of these are kind of crash prone, sometimes just one of them are. So the first one we're going to do is model items. So we have our view layout, and this is going to let us that, you know, we can do all sorts of different stuff with here. This is going to be our standard 3 view, you know, projected, auxiliary. We can also do like detail or section views. It's like if I wanted a section view of this guy, I could click here, click OK, and now it's going to create a section view. Give it the scale and all that. Don't want that. Detail view is going to, you know, do the same or similar deal. Right. So all the views you know and love from blueprint reading. Breakout, you know, broken views, crop views, all that. Should be pretty self-explanatory. In the annotation function, that's where we're going to put in our dimensions. And so we can do this a couple different ways. The first way is we could just go in here and manually dimension everything. Oops. What happened there? All right, so we could go in and just manually dimension everything. Right, we could do that, but the problem with that is we already did this. Right, we already dimensioned everything. We already put all of our dimensions in there to make sure that they were right. So instead of going in and redimensioning things, I'm just going to do model items. So model items, I want my entire model, and I want to import items into all views. If I don't have this selected, it's just going to do whatever view I have selected. And if I don't have any selected, it's going to say, hey, do you want to just do the entire model? So just go ahead and switch it to the entire model. It's not going to put dimensions on our ISO up top, but it will put any dimension that we have or that we have defined in our part. And so from here, we want to select not marked for drawing because we didn't mark any of these for drawing. We want to do whole wizard locations and whole callouts. You can do instance revolution counts, you know, tolerance dimensions, all that stuff. And we want to import items in all views. So let's do tolerance dimensions as well. And then we can stick this stuff in here if you have datum references, if you have GD&T references, if you have weld symbols or finished surface callouts. And then reference geometry, right? We could include our center lines or axes or our reference planes, that sort of thing. Probably you're not going to want to use that. So when you click OK, it should drop down almost all these dimensions into your part. Now, the trick with this is sometimes it will have, like in this case, duplicate dimensions. Sometimes it'll have dimensions that aren't really what you're looking for. Right. So usually you're going to have to go through and kind of move stuff around. So like this is a really good example right here, right? So I have this whole call out. Well, first of all, depending on how I wanted to do this, right? If I wanted to have this diameter on this hole, right now this diameter is to 2 decimal places. So 3 decimal places would be a lot more useful. But when I change it to 3 decimal places, that also changes the tolerance. So in this case, what I could do is change this to, well, not none. What I could do is override this dimension. So if I go over here to override units, right? So in my value, I have, or up here in my feature manager, I have value, leaders, and other. So override units is going to allow me to change this to leave it in inches, but I can change it into fractions. And let's say 16ths. Now you can click OK, right? So that changes it to 2 times 3/16, right? So instead of having a 0.188, which means that this is going to have a 3 decimal tolerance, you know, or 5 decimal, you know, not 3 decimal, 3 thousandths tolerance most of the time, or maybe 5. Well, now we have 3/16, so that gives us a 1/64 tolerance. So, but anyway, this isn't necessarily the best place to stick this, right? Because this is going to be, I got this line crossing the outside of my part. It's going to have to, I really don't like to cross extension lines. I feel like it adds a lot of clutter. So one of the things I like to do is try to space all this stuff out. So what I can't do is just say, all right, point at this hole instead, dude. So, you know, there's no way I can set this up here, but it's actually pretty easy. When I click on this dimension, you'll notice there are all sorts of arrows that pop up around here, arrows and dots. So what these arrows do is allows me to adjust my dimensions. All right, so I can kind of adjust my break line here. I can make it super long. If I needed to pull it way out of the part, I can make it super short. I can obviously make this way shorter. I can change how this is called out. So instead of calling out from just pointing at the circle with an external arrow, I can change it so it has 2 internal arrows on that circle. And then I have this little dot right here. And this is the dot that determines what feature this is pointing at. Right, so if I take this and I grab that circle, I can't drag this to anything but another circle. Right, it won't even let me think about dropping it anywhere but another circle. But what's really not going to let me do is select anything other than a feature similar to this, or a feature that this is also called out with, right? So we have a 2x, so I can actually drag that that call out to that hole over here, right? Which puts it outside of my part, much further outside of my part, which is going to let me make this, quite a bit clearer for people. All right, and that's kind of one of the things that you need to think about when you're making blueprints. Is this not just, well, maybe it is just you that's going to be reading this, but it might not be just you that's going to read this. So you kind of want to come into it with that sort of thought process: is how can I make this the most readable for the most people? And we've all seen bad blueprints out there, and a bad blueprint just makes your job way, way harder. All right, so one of the things you probably noticed is when I changed this, or when I pulled this over, now this is like kind of a gray instead of a black color. Okay, because Solidworks for some reason thinks that me calling out this hole is a better dimension, or a more solid dimension, than me dragging this over to this hole, which is the same damn hole. So this is what that setting was in options in their document properties, or I'm sorry, in system options for colors. And this is that dimensions non-imported driven. So a driving dimension is a dimension that is driving the shape of that part. A driven dimension is a dimension that is driven from the shape of that part, or from what that part is. Maybe, hopefully that makes a little bit of sense. But what I'm going to do here is I'm just going to edit this color, and I'm going to make this black. And click OK. And so you might have seen that there. Changes this dimension from gray to black now. And the reason why I do that is because if you leave this gray, it will print gray on your blueprint. When you print this in black and white, it'll print this dimension as lighter, which can make it more difficult to read. All right, now we're going to just change two more things about this print. The first thing we're going to do, the next thing we're going to change is this down here. So right now, for some reason, it defaults to our file name. Excuse me. It defaults the file name into the drawing number for this part, which I've always thought was a little weird. So in order to change this, what we're going to do is we're just going to right click down here, and we're going to edit our sheet format. So edit sheet format is going to change everything, allows us to change everything about this sheet other than their actual part that's on here. So when we edit sheet format, basically what that allows us to do is edit our title block. And so from here, we can drag and drop these around. So these are technically text boxes. So what I'm going to do is I'm just going to kind of change the shape of said text box, and then I'm going to drag it back down so it's in our title page. And I'll drag it. So all right.
It's really just not liking you there.
No. See, and that's the thing, is like it looks terrible while you're doing it, but then you let it go, and it's like, oh, that's exactly what I thought it was going to do. Some of these things, some of this stuff works better than others. This is really the biggest reason to make a template in SolidWorks, though, is to create your blueprint templates, because things that you want in there are like your tolerances, right? So, our fractional tolerance is going to be, oops. What is going on here? Why won't it let me edit this? Oh, it is letting me edit it. It just won't show me where my, oops. Angular. So these are your angular tolerances for machining. That's the mock, and bending. So we don't really do a whole lot of bending in here, hopefully, not on purpose. And then our, might be a half degree. I can't remember what our normal. Let's see if I can remember. Yes. If you hold down Alt and hit 176, that is the shortcut for your degrees. And 2 decimal place tolerance, let's just say 10. 3 decimal tolerance, say 5. And 4 place decimal. Oops. Nope, that's not it. Okay, Alt 0177. Yes, all right. All right, so then that would be basically your title block. And you could obviously come in and have other information in here. Don't know why it's not updating material. Should. But what I was saying earlier, right? So that looks pretty good as far as our title block. I mean, we don't have to put in, for our purposes, we don't have to put in draw and checked, engineering approval, manufacturer approval, and all that, quality assurance. What we would want to do is go in here and get rid of duplicate dimensions like 970 and 965 and so on. All right, so I'm going to click save again. And now I'm going to show you the, lots of times is Crash City for these guys. And that is Format Painter. So Format Painter should be one of those things that is really, really super helpful for us. There's a lot we can do with it, but for some reason it just doesn't work all the time. So what Format Painter is supposed to let us do, Format Painter is supposed to let us take one dimension that we get set up exactly how we want, right? So like, let's say all these dimensions were in 2 decimal places, this is in 3 decimal places, but I want to change everything to 3 decimal places. So what Format Painter is supposed to let me do is supposed to let me select a source and then copy that to my other dimensions. So what it's doing is just taking the format of this dimension and it's applying it to all the dimensions I clicked on. So you can kind of see that it kind of looks better. So this is the problem that I have with blueprint making, is the longer I look at it, the longer I'm like, well, I can move these dimensions around, make it just a little bit clearer, a little tighter. So as you can see, what it does, it copies that 3 decimal place to other spots, right? So, if I had this dimension here and I wanted to change everything to 2 decimal places, I can do the same thing. It'll work with any dimensions. It used to be a lot more useful because the defaults for these dimensions in SolidWorks used to be really stupid. Used to put everything at an angle, all sorts of fun. Any questions?
I'm good.
Okay. So that's really all I wanted to cover. From here, saving it is just like saving it in another file. If we needed to print this out, sometimes your printing can be a little funky. Sometimes you have to, it'll try to scale this over multiple sheets of paper. Nothing really any different than any other printing anything else. Just be aware of what your settings are and all that stuff. But that's pretty much it. I mean, that is making blueprints in a nutshell. Obviously, well, hopefully, obviously not all the dimensions we're looking for are on here. Sometimes it will not call these dimensions for whatever reason as to how they were drawn or dimensioned. Sometimes it just won't pull a dimension up for it, but I think this is I think it's pretty good. All
So
right, well,
is this something that's going to be part of our homework? I guess.
yes. Yeah. So what I was going to have you guys do is make basically just draw parts 5 and 6, or make models for parts 5 and 6, and then create blueprints for all the offset boring head parts.
Cool beans.
So, but once you get, once you get your template set up, once you get your first print or 2 made, it's really more of a repetitive process than anything. But we'll talk a little bit more about templates and that sort of stuff tomorrow. How to get this set up so it'll kind of streamline your process. But I think that's kind of a good stopping point for the day.
All right, sounds good.
All right.
Okay.
Well, have a great day, guys, and hopefully I will hear you tomorrow. Not see you. But all
Have a
right.
nice day. Stay safe.
Thanks. You too.
See ya.
Bye.